Now, an emulsion, a very serious emulsion, happens when the two layers don't separate at all. And what happens is you'll get a solution that looks very, very milky between the two layers. And what you'll see here is you can actually sort of see a slight emulsion between the two layers here. You see those bubbles and the interface between the two layers? This does not seem to want to separate. Now, emulsions, the general rule for emulsions is you want to try to avoid them, because it's much easier to avoid them than to deal with them once you get it. Like I said, chlorinated solvents, aromatic solvents, tend to be more prone to emulsions. This is not a very bad one. In the case that you get a more serious emulsion, there are several ways to approach this. You can add a small volume of saturated sodium chloride. What that does is that saturated sodium chloride, you add it to the aqueous layer, it dissolves in the aqueous layer, and it makes that solvent more polar. And now the difference in polarity between the two solvents is larger, so therefore it causes the two to separate. In this particular case, the emulsion is not bad, and you'll have to follow the general procedures that you have in your notebook or your lab experiment. And in general cases, you'll leave the emulsion with one of the two layers. Okay, so in this case, we want to put our organic layer. The bottom layer is our organic layer, so we'll take that out. And I'm going to use the Erlenmeyer again, and we'll repeat the same procedure. I'm going to keep the emulsion, in this case, with the dichloromethane layer, with the organic layer. Okay, I stopped it here just so you can see it here. You can see it a little more clearly now that it's become a little bit larger. But you can see the interface, the dark brown or the light brown there, with a whitish material there, milky material, and that's your emulsion. It's just a point at which the two layers are not separating. In this case, again, we're going to put this with the organic layer. And we'll stop it when that's done. And we've completed our extraction here. Again, we have to remove the top layer. In this case, our top layer is our aqueous layer from the top of the separatory funnel. So one of the most common is if you leave the stopper in and then you decide to open the stopcock to remove the lower layer. Now, as you can see, I opened the stopcock is completely open, and just a little bit of solvent has gone through, and it stopped. Nothing else is going on. So this usually causes students a tremendous amount of frustration because they're looking at it and they can't quite figure out why it's not, the solvent is not moving. And that's simply because you haven't removed the stopper. So you'll notice once I remove the stopper, the solvent starts to move. Okay, so I'll let that go all the way to the bottom here. Okay, so the last source of confusion, not really a source of confusion, but more of frustration, is when you start to add your solvent or your solution to the separatory funnel, and you forget that the stopcock is open. Okay, so obviously you can predict what's going to happen here, but if you are simply not paying attention or distracted in some way, and that stopcock is open, you pour it in, and it simply goes right through. And if this is your final step in a synthesis, you have to isolate this, and obviously it's going to put you a little further behind, and you don't want to do that. Okay, so that's the last source of confusion for extraction.